Chapter 18.1 Introduction to Non-Parametric Statistics. Parametric statistics describe procedures that assume that the population from which a sample is drawn follows a known probability distribution, such as the normal distribution. I hope this definition sounds vaguely familiar to you because it is essentially what we have been doing since Chapter 8. The following are instances in which parametric statistics have been used in previous chapters of this textbook. Confidence interval for the mean of population when the population standard deviation is not known, especially when the sample size is small, Chapter 8. Hypothesis test to estimate the mean of single population when the population standard deviation is not known, especially when the sample size is small, Chapter 9. Hypothesis test for comparing two population mean when the standard deviation of the population are not known, especially when the sample size are small, at Chapter 10. Hypothesis test for comparing more than two population means using the analysis of variance techniques, Chapter 11. Parametric statistics also have requirements related to data measurement level. Recall from Chapter 1 that there are 4 levels of data measurement: nominal, ordinal, interval, and ratio. Table 18.1 describes the level and provides an example of each. Parametric statistics require the level of data measurement to be interval or ratio. The hypothesis test and confidence intervals that estimate population means cannot be used for data that are at the nominal or ordinal level. The question begging to be asked at this point is, what do I do when the underlying assumption or requirement for my parametric statistical procedure are not satisfied? The answer is non-parametric statistic. Non-parametric statistic is a term used to describe procedures that rely on fewer assumptions about the probability distribution for a population of interest than parametric statistics do. Non-parametric statistics also can be used for data that are at the nominal or ordinal level of measurement. Finally, non-parametric statistics can be used to perform a hypothesis test to estimate the population median, which parametric statistics cannot do. This raises another question that is begging to be asked. Why don't we just estimate the population mean using non-parametric statistics so we don't have to worry about the assumption and requirement of parametric statistics? As I have said before in this textbook, there is no free lunch with statistics. All else being equal, the same sample size, the same of significance, and so on, the parametric procedure will result in a higher probability of your correctly rejecting the null hypothesis. In Chapter 9, we refer to these probabilities as the power of a hypothesis test. A statistician prefers a test with a higher power to a test with a lower power. One last question begging to be asked. How do I decide when choosing between a parametric procedure and a non-parametric procedure? Because the power of parametric procedure is higher, you should use it when the required assumption about the probability distribution of the population can be verified. By contrast, use the non-parametric procedure. If the level of data measurement for the sample is only nominal or ordinal, when the sample size is very small or less than 30, because it will be difficult to test if the population is normally distributed. When there is no corresponding parametric procedure for the hypothesis test, such as a test needed to estimate the median of population. For, for some hypothesis tests, no parametric procedures exist.